So we are looking at 1.3 today. And do you notice that all of these graphs are BFFs? There's just some transformations going on. So we had to learn our BFFs. So now in 1.3, we can do transformations. And so to start our transformations, I'm going to give you a very basic equation, okay? So we'll start knowing that generally our equations are f of x. But when I do transformations, I can have 4 different places that have numbers that will transform my graph, okay? I can have a number times the outside of my function. I can have a number times my x inside what the function is doing. I can have a number being added or subtracted inside my x, or I can have a number on the outside being added or subtracted. So I use A, B, C, and D to kind of put a placeholder in each spot, and then we'll talk about what that does to each part of my graph. Okay. Now the first two I think should be pretty simple. Do you remember what happens when I add or subtract something to the end of my equation? It's not inside being done stuff too. What does that do to my graph? Moves it up and down. Good. So if I have like a +2 or a -1 on the outside, that moves it up and down. And it moves it exactly how you think it should be moved. If it's up, it's plus. If it's minus, it's going down. So I like to say, okay, that's exactly what I think should be happening. Up and down. What if I have a number being added or subtracted inside my parentheses? Left or right? Very good. Now that one is different because it's opposite of what you think it should be. If it's left, it's positive, and if it goes right, it was negative. So those are all transformations that we should be pretty familiar with. And those are ideally the only ones we're really working with. I'm going to tell you about the B and the A really quick, but we're not going to do a ton with that right now. B is also inside with my X, which means that it's going to affect the X. Left and right is a horizontal direction, right? If I have a number being multiplied by my x, that's going to shrink or stretch it horizontally. It's going to make it go a little bit tighter, or it's going to make it stretched out a little bit longer. So it's a horizontal stretch or shrink. And then that A out front, it's the same idea. It's still a stretch or a shrink, but this time it's a vertical stretch or shrink. So it's stretching and shrinking it long ways instead. Another thing we could see in that A spot in front of my whole function is a negative sign. Do you remember what the negative sign does to my graph when it's out front? Flips it. Do you know how it flips it? Does it flip it like across the x-axis or over the y-axis? X-axis, very good. It flips it across the x-axis. It essentially flips it up and down. So it flips it over this axis right here, which is the up and down axis. That being said, we probably won't see any of these today, but if we had a negative that was in where that B is, a negative inside with that X, that's not going to switch it up and down. It's going to switch it left and right across the Y axis. So if I have a negative on the inside, it's going to go across the Y axis. Like this, back and forth like that. All right, we had to review that, and now we're just going to graph these graphs. We know what all the BFFs look like, so it should be a really easy sketch for us. And we're just going to decide are we moving up and down, left and right, stretching, shrinking, flipping. What are we doing with these? Okay, so we'll walk through at least the first couple, if not all of them. Okay, so what is that +1 doing to my graph? To the left, very good. And you can write off to the side left 1, especially if you're not sure if you did it right or wrong. That way you're kind of showing me that you know what you're supposed to be doing. I'll move it to the left and then remind me what's that shape going to be of that graph? A V, very good. What about that next one? Is that -2 going to move it up and down, left and right? Right, very good. Let me take attendance before someone has to call in. No, we're good. And what shape is that gonna be once I move it right? A parabola, very good. Should you guys go ahead on your own, or do you want me to keep walking with you? Okay, I'll keep walking. All right, what about the next graph? What does that two do to my graph? Down, good. So I know you're like, oh, I don't know what it's gonna do to the ln(x). That's okay. First thing I know is it's gonna move it down. So instead of being up at 0, 0, it's gonna be down 2. Now, what does my ln graph look like? Do you remember? Yeah, so it starts low and then it goes high. Normally it goes through the point 1, 0, but since I'm moving down 2, it's gonna go through the point 2 or 1, 2, -2, I guess. So I'm gonna just kind of zoop like that. It is gonna go over the x-axis just a little bit. And then remember, this one technically has an asymptote. My asymptote doesn't do anything, it doesn't move, it doesn't change though, just because I moved down 2. It still stays, it didn't go left or right, and it just stays where it's at. All right, looking at that next one, what's that negative going to do to my graph?
Flip it.
Flip it. My reciprocal normally has like little C curves in which quadrant? 1 and 3. So when I flip it, where's it going to be at now? 2 and 4. Very good. So a little C curve over there, a little C curve over here.
That's a flip over the x-axis. Or sorry.
This is a flip over the x-axis. It's an up and down flip. Because it was up here, and then now that flips down there. Now, is this going to look the exact same, though, if the negative was just inside of the x? Absolutely. All right, what about the next one? What does that +1 do? Up, very good. It moves it up 1. And then we know our square root function is just a little zoop over to the side. What about f? What's going on there? What did we say? Right, 2, very good. 1, 2. And then we know a cubic is a little snaky, kind of snakes through the middle. A little curvy. A little squiggly. 3 more like this. Ooh, we've got a sine one. What does this plus do to my sine? Up 2. Okay, we already talked earlier today about our sine going through which 2 points. It goes from what to what? -1 to 1. If I move up 2 units, now what is it going to go between? 1 and 3. So that -1 has to move up 2 units, 1, 2, which means 1 is now my lowest point that I can be at. And then the 1 was the highest point, and now it has to move up to 1, 2. Now it's up to 3. Does sine start at the top of my graph, or does it start in the middle of my graph? In the middle. Normally it starts at 0, 0. So I had to go up 2 units, which makes it go through 2, 0. And then now I'm going to wave. And we're trying to keep even waves, and we're trying to go all the way up to 3 and all the way down to 1. Yeah, if it was cosine, the only difference is it would be through 3, 0, because so it's because it would normally start at 1, 0, 1, and I have to go up 2, so I move it up 2 units. And so now that I've moved it up 2 units, now I'm at 3. It's still going to stay between 3 and 1, so it's going to look more like this. Yep. If this said cosine instead of sine, cosine still goes between 1 and -1. And so when I move it up, I'm just moving these up. My scale is off, but it should be 1 and 3. And I'm sure you guys are so excited and can't wait, hardly wait, but we're going to do lots of transformations of sine and cosine next semester. And we'll even have more rules than this, so. I know you're thrilled. Hold your horses though. All right, what about the next one? What graph is this? Exponential, and then what is this one doing? Down one. Now remember exponential's fun because it has what special feature? Asymptote, where at? At the x-axis.
Yeah,
So if I'm normally at the x-axis and I go down one, where's my asymptote now? -1. So I gotta draw my asymptote down here. Normally my exponential goes through the point 0, 1, so now it's gonna go through 0, 0. As long as it hugs the axis and then pops up, we're good. All right, and then very last one, this negative in front of my absolute value, what does that do to that? Flips it down, very good. So my V shape is now gonna be in the third and the fourth quadrant. All right. Cool. So you know your quiz is going to be a graphing calculator. I'm probably not going to make you do a bunch of these because this was all by hand, right? So if that stresses you out, you can always graph it on the quiz the next day. Now, would you expect a bunch of or like at least some of these on the test next week? Absolutely. But for the quiz this Thursday, don't worry about that because it's a graphic calculator one. Okay, what I want to do right now is I want to be quiet. I want you to spend a little bit of time with each other. I want you to see if you can figure out our BFFs and do A through F. We can go all the way through F. Not just the 9 above it, but I want you to use your actual BFFs up here. I want you to see if you can decide which 4 functions that are odd, which 6 functions that are increasing the entire domain. So feel free to turn and talk to a neighbor. Feel free to do it by yourself. I don't care. But I want you to see how much of 2A through F you guys can do, and then we'll talk all together. Ready? Look at your BFFs. Go.
oh, right.
It's all BFFs. All BFFs.
Oh. Another odd.
Do you want us to look up like the name of the name?
Look, either do the equation or the name. So I'd either write identity or I'd write just X. Thank you, Miss Macy. All right, let me write you a pass.
Like,
Yeah, I'm so sorry that we had to go through that rigmarole, but hopefully everything's all good.
it worked out. I need to get back in the gym, dude. Dry, no? Wake up and.
Thank you.
When you're
Yeah. Like this, like that. Instead of. Yeah, no, I'm sure. I'm not. Hold it. Yeah, this is odd. That's all. That one's not. Yeah, right. I look. Yeah. I looked at all. There's so many. Like this thing.
I think we did get those.
Yeah.
Yeah. Gus, did you do A through F?
I got like questions.
Talk to a neighbor. Talk to somebody else.
That's why we're for a loss.
Say one more time,
We're for a loss.
then skip to the next one.
Woke up this morning.
Do as much as you can, A through F, and then we'll talk about it. Don't worry, I won't leave you lost for too long, but I need you to struggle a little bit.
Domains are increasing. Absolute value. Yeah. Where the function. Where the function. No. Which one? Yeah. Like that's small, I mean. Oh, wait, no. Oh, wait, no, it might be. No, no, yes. It's gotta be cute.
What do you
Are you sure there's only 3 that have a range?
A range. A range. Not a real name.
It doesn't go straight down.
What is that, exponential? No, because that has an asymptote.
Yeah, but the range.
That's the range.
Oh.
There we go. Talk to somebody, talk to anybody. Anyone in this whole class would talk to them. Join a group, talk to a single person.
It's like, I can drink a lot of it. I'll be quick.
Can we find a positive point in 2 minutes? 2 minutes?
Oh.
It's like the, Amber, what? Yeah, very small and.
What's that?
Here you go.
I think I always do that, don't I?
Yeah, I just almost, if there was somebody, you might definitely go to the party.
No, I'll go over why.
These cards so far. I think I was like, just so you know, these cards sounded.
Yeah, I heard you.
Shut up.
Didn't you come up with it? And you came up with it.
All right, it's been 2 minutes. Find a stopping point. Go back to your desk. All right, everybody's with me?
Yep.
Perfect, okay. First one says, four functions that are odd. What does odd mean? Or where am I looking to know what odd is? The bottom, not necessarily the bottom,
Oh, like, the,
kind of diagonals, Amelia.
And the fact like the end behavior where odd is opposite, it's like, we're like the two ends, like you're the
Not just that. That is true. Quadrant 1 and 3, because this is a symmetry issue. This is symmetry. And if it's the same symmetry, if it's the exact same graph in Q1 and Q3, then it's odd. So I love that we're talking about odd end behavior, which we will talk more about when we get into our polynomial section. When I talk about odd with BFFs, I mean the symmetry is odd. And that should just be like flat out written on your paper, right? Like the first one that's odd that I know is identity. So that one counts as odd. What's another one that counts as odd? I guess I'll look at this. Reciprocal counts as odd. Very good. It's the same in 1 and 3. And that's the value's not. Sign is. Sign, because I told you when we were looking at when we were looking at it to just kind of look at that little box, and that would be odd. So we did identity, we did sign, we did reciprocal. I can think of one more, Devin. Cubing, very good. A cubing function is a lot like identity. It is odd as well. Remember also, let me write those down. And you can write them however you want. I'm mostly just going to write the equations. Remember also that when we're talking about odd and even symmetry, we did that the other day in class, where odd symmetry is if I plug in a negative x, then I get a negative answer. So like if I do my cubing function and I plug in +2, I get out +8. And if I plug in -2, I get out -8. So an odd function, if I were to plug a number in or plug x in, I would get the negative of that function back out. Okay. All right, the next one says 6 functions that are increasing on their entire domain. I will tell you in alpha, we thought about 7, and there's one that I could argue yes or no, depending on what we're doing. So what's one that's increasing the entire domain? What's one that we're thinking of? Avery, give me one. Identity, good. The entire domain, remember when we're doing increasing, decreasing, we're starting at the left and we're going to the right, and it's going up the entire time. So identity is 1. What else? Cam? Cubic, yep, those are almost the exact same graph. As we go across the page, it's going up. Identity, cubic, let me write those down while we're thinking about it. What else do we got? Yep, Kate. Exponential, very good. Exponential is right here, and as I go across the page, my x is increasing, or my y's are increasing. What else? Greatest integer was the one that, like, I could argue yes and no. I think this is like the 7th one that we found, because as we're going across the page, technically, like from here to here, it's not increasing, it's staying constant, and then it jumps up, and constant, and then it jumps up. So I think that's why it's not counted. But if we count that, and that can be our 7th. So we'll say exponential and greatest integer. Yep, Kate, what's another one? Natural log, very good. Natural log is the same idea as my exponential. It starts low, and then as over its entire domain, it's increasing. Square root is another one. And logistic, very good. As I go across the page, that logistic is increasing the entire time. So logistic.
there's why would sign cosine like that?
I'm signing cosine increasing the whole time. No, they're going up and then they're going down, and then they go up and then they're going down, and then they're up and they're going down. So 1, 2, 3, 4, 5, 6, 7. Yeah, so last period decided 7 was good. 3 functions that are decreasing on the interval from -infinity to 0. So that means on this part of the graph, it's going down over here. So it's starting somewhere and it's going down as we go across that page. Pick any one. Squaring, very good. Squaring starts high and it goes down until we hit the origin, and then it comes back up. What's another one? Nope. Absolute value, and absolute value and squaring look very, very similar. The V versus the U is almost the same. And I got one more. Reciprocal. The reciprocal is kind of a funky graph, and we forget about it sometimes, but if you look at it, as I go across the page on my domain from negative infinity to 0, it is going downwards the whole time. So that makes it be one of those, decreasing. So I'm doing a lot of slides back and forth, but I'm trying to demonstrate. Okay, if I'm looking at the next one. On the next page, it says 3 functions with no zeros. What's a function that does not have a zero? Reciprocal doesn't have any zeros. Exponential. Logistic. What is interesting about all 3 of those graphs? What do they all have in common? They are not all odd. Asymptote where at? Or what kind of asymptote is it? Horizontal, right? It's a horizontal asymptote at 0. There's no way that it could be there's no way it could hit the axis, the x-axis, if it has a horizontal asymptote. Bonus, what's the other graph that has an asymptote? There's only 4 that have asymptotes. What's the 4th one? We already said reciprocal. Natural log. But what kind of asymptote does natural log have? A vertical one, so it will cross that x-axis. All right, 3 functions with the range of all real numbers. So we want its range to be negative infinity to positive infinity. Identity. Cubing. Natural log. There we go. All right, and then one more that I think you could have attacked. There's 2 functions whose graphs are identical except for a horizontal shift. Which 2 are the exact same graph, but it's just shifted over? Ooh, did I hear it? Oh, not reciprocal. Joey, what'd you say? Sine and cosine. Very good, Joey. Let's go look at those. Okay, so we'll do cosine. So I'm going to take cosine. Here's my cosine graph. I'm just going to kind of sketch it. Don't sketch yours, just kind of look at mine. That's about what my cosine graph looks like. It's not perfect, okay? If I were to take this up with me, I'm going to take this up with me. Oh, did I break it apart? I'm breaking it apart. I want it broken. I want it all together. Good enough. When I take it up here with me to my sine, notice that the way it starts, this is where my cosine is. It starts through 0, 1, 0. When I shift it over, notice how they're going to line up. Now mine aren't perfect because it was just a sketch, but it's supposed to line up on top of each other. It was over here, now it lines up right on top of each other. So sine and cosine are just a horizontal shift away from each other. You see how that works out? I know that's not a great example, but it's as good as it gets with the sketch. So it's going to be sine and cosine. Now, the last 2 require some end behavior, and I realized that we hadn't talked about end behavior yet. I made you leave those blank. We're going to go back and fill in all of our end behaviors now that we talk about it. I'm going to use this notation. Have you guys seen this notation before? I expect no. I expect you've never seen this before. However, what I do expect you to have seen is as x approaches positive infinity, y approaches. Have you done that before? Yeah. Okay, perfect. This is the exact same thing. Limit notation is just a calculus topic. So remember, we are in this class called pre-calculus. A lot of what we do is not calculus stuff. A lot of what we do is not necessarily going to get you ready for Calc 1. It's all algebra stuff. We aren't talking about derivatives. We're not talking about integrals. Those are all things that you do in Calc. But this limit notation, you start every year of Calc 1 with limits. And so this is the only pre-calculus stuff that we're going to do together, okay? The way we read this says the limit of my function as x approaches positive infinity is blah, blah, blah. So like we'll start the limit of the function, the limit of, and you don't have to write that down, just that's what I'm reading out loud. And the function is your y. So you can think of that f of x as being your y. The bottom right here tells us what x is doing. So in all cases, we're going to have to look at as x approaches positive infinity and as x approaches negative infinity. And then we're going to see what the graph does, okay? So we'll go do our, all of our absolute values and then, or my limit notation, and then we'll come back and look at these two together, okay? So go back to the beginning of your BFFs. And we are now going to fill in all of these end behaviors. I'm hoping to get through all of them with you, but if we don't get through all of them, I'm going to ask you to finish them for homework, okay? So that we can use it moving on. The hard part about end behavior, and this is where you guys were losing or lost me with the increasing and decreasing, or where I lost you, I guess, is that end behavior, you start in the middle and you go outwards. So I start in the middle and I say, okay, what's my graph doing as x gets closer or big, it's smaller and smaller and smaller, and then what is my graph doing as x gets bigger and bigger? Let's set up our notation. So on all of these, we're going to have both of these. We're going to say the limit of my function as x approaches negative infinity is, and then we'll put a number there. We'll also do what's the limit of my function as x approaches positive infinity, and then we'll put an answer there. I'm writing LIM, like limit. I just do it in a little bit of a cursive letter. So LIM and then FX. There's no neater than what I did. Okay, so if I look at this graph, as I approach negative infinity with my x's, is my y going up or going down? Down, right? Negative infinity. So my limit of my function as x approaches negative infinity is also negative infinity. Now when I go to do my positive, as x approaches positive infinity, what's my graph doing? Positive infinity is going up. So we'll say that's approaching positive infinity. There are really only three common answers. It's positive infinity, negative infinity, or any asymptotes, whether it's at 0 or 1 or 20, whatever that asymptote is, we're going to use. Okay. So this was what we called an odd function because we're going in opposite directions. My end behavior for this next one is going to be a little different. So I'm going to set it up. I'll do limit of my function as x approaches negative infinity. And I'll also say limit of my function as x approaches positive infinity. As x gets smaller and smaller, what's my y doing? Getting bigger, it's going up. So we'll say that's positive infinity. What's my graph doing? Oh, it's my function doing as x gets bigger and bigger. Also getting bigger. So we'll say positive infinity, positive infinity. So this one, my end behavior was in the same direction. Cubing function, is that one like identity or is it like squaring? It's like identity. It's the exact same thing as identity. So I don't even have to look at my graph this time. I say limit of my function as x approaches negative infinity. I know it started by going low, going to negative infinity. Same thing, limit of my function as x approaches positive infinity. It's going up, it'll be positive infinity. So go ahead, flip your paper. Now my reciprocal function here. As we approach negative infinity, as I go this way on my graph, what's my y getting closer and closer to? 0. It's getting closer and closer to that asymptote. I told you a second ago your common answers are positive infinity, negative infinity, or an asymptote. In this case, it's the asymptote. What about as I approach positive infinity? Also 0. It's coming at it from the other side, which will be an important thing to talk about when we get to calculus. But for right now, either way, it's approaching 0. As the graph gets bigger and bigger or smaller and smaller, it's getting closer and closer to that asymptote, to 0. Now, the square root function, do we have anything as x approaches negative infinity? No. So you can either just not write it, which is what I would do if I were you. Because I'm on my calculus kick, let me tell you, in calculus, if they ask you for it, And there's nowhere on the graph where X is approaching negative infinity, there's nothing over here. We write D and E does not exist. Have you guys ever seen Mean Girls? There's a point where Katie Heron goes, the limit does not exist. D and E, the limit does not exist. I really date myself with that reference.
Can we just write it? You have to write the one.
Think not expressing. You can, I'd write D and E. Or if I were you, I wouldn't even write one for this one. I just wouldn't write that one. But positive infinity, as X approaches positive infinity, what's my graph doing? Also going at positive infinity. All right, on my exponential one. As X approaches negative infinity, what's my Y approaching? 0. My asymptote, it's getting closer and closer to that asymptote. It's not going to negative infinity, it's getting closer and closer to 0. But as I approach positive infinity with my X's, what does my graph approach? Positive infinity. Natural log is another one where I don't have any negative X's, so you don't have to fill that one out. So I only have one, I have my positive X's. So I'll just do limit of my function as X approaches positive infinity. And what's that gonna be? Positive infinity, good, good. I don't want you to do one at all for sine and cosine. So we're just gonna put little X's there, X, X. It doesn't approach anything. What is absolute value the most like? Positive, positive. What's greatest integer? Negative, positive. The logistic one's a funny one. As X approaches negative infinity, what does Y approach? 0. It approaches that lowest asymptote. And as X approaches positive infinity of my logistic function, what does Y approach? 1. Very good. I'll go back and write the other ones too. All right, so if you finish those, you don't have any homework tonight. If you didn't finish those tonight for homework. We'll finish 1.3 tomorrow. We'll talk about your quiz tomorrow, and then Thursday we'll quiz. What's up? Yeah.